Hello, welcome back to Idea Statica tutorial. Myself Jarajan P. This is tutorial number 24. There have been requests to provide a video tutorial to demonstrate the concept of mode of application of load effects in Idea Statica. Accordingly, this tutorial considers a simple truss joint to demonstrate the same. So as you can see, the title of the presentation, that's the load effects by standard or advanced mode. So the simple truss joint model that is used for the demonstration is used here. So now let me give a brief review of the problem definition. In Idea Static, as we know, one member of the joint is normally set as bearing, whereas the others being connected. The bearing member of the joint shall be judiciously chosen by the designer based on the design objective. The bearing member can be either continuous with the supports on both ends or can be ended with the support being provided only on one end. Now in Idea Statica, we have two modes for the application of the load effects. One is known as the standard mode. In this mode, the bearing member is supported and the load is not defined on this member. In the second mode, known as the advanced mode, with equilibrium check, the bearing member in this mode is supported on one end. The loads are applied to all members and the equilibrium is checked. Now, how do you do the switching between these two modes? The switching between the modes is done using the ribbon group available in Idea Statica, and this ribbon group is named as loads in equilibrium. So now the obvious question is, when shall we go for the standard mode or to skip standard and go for the advanced mode? The answer is given right below. The standard mode can be used when the designer is interested in studying only the connector members and not the behavior of the whole joint. However, where you require a detailed check of the bearing member as well, obviously you should go for the advanced mode. So let us start the Idea Statica tutorial number 24. Please note that the link for the playlist for all previous tutorials is given in the description of the video. So the simple truss joint model that is used for the demonstration in this tutorial is shown here. As you can see that it essentially consists of a top beam member which I have selected as an HE 140A European section, and as you can see that it also consists of three bracing members, one being vertical and two being diagonal, and all the three members are connected to a gusset plate that is welded to the beam. Now for demonstration, I have generated two projects in this file. As you can see that here one project is con1 and the other project is con2. I will use the project con1 to demonstrate the simple mode of application of the load effects, and the con2 that will be used for the demonstration of the advanced mode of the load effects. So just to explain the model, as you can see that in this model, the member B1 is the bearing member. So you can see that the member B1, it is provided with the two supports at the ends because it's a continuous member. Now in this tutorial, I won't be explaining the details regarding the manufacturing operations and the members because we want to focus only on the method of or the mode of application of the load effects. So as you can see that, so the load effects is very important and is the focus of this tutorial. So here I am in the simple mode. How do you know whether you are in the simple mode or in the advanced mode? If you are in the simple mode, you will find that, okay, so in the table for the application of the load effects, you will find that the beam B1 is missing. Yes, you don't have the beam B1 because this beam B1 is defined as a bearing member. So accordingly, in this simple mode, you will not be able to apply the loads at the ends of these members B1. So, and as you can see that the loads could be applied for all other connected members like BR1, BR2, BR3, And the same is done here. For example, here you will find that, just a minute. Yes, you can see that, okay, for example, this member, that is the BR1, is subjected to a compressive load of 344, and the vertical bracing member is subjected to a tension of 150 kilonewton, and again the other diagonal member is subjected to a tension of 156 kilonewton. So we are unable to apply the loads on the bearing member B1, right, because we are in the simple mode. Now here, once again, please note that here the loads in equilibrium tab, it is not highlighted. That means we are in the simple mode. Okay. So now let me quickly run this model to just see, okay, how does the various components fit for this load combination. Okay. So I will just run the model. So this may take some, I think, 5 to 10 seconds. So once we run this model, what we do is that we just investigate the various components, like for example, the utility ratio of the bolts and the wells, etc. So yes, it's a simple mode. The analysis is run. So here you please note down. You just remember the utility ratios. For example, the plates have been taken to a strain level of 0.5. Okay, good. That is less than 5%. And the bolts are being taken to 94.9%, and that's also less than 100, and the wells 57.9. Okay, so, and in addition to these parameters, what I would also like to show you is the distribution of the stresses in all the members, because whether you apply the load in the what I want to say, that is simple mode, or in the advanced mode, we expect that both the results like the that is given here for the plates, bolts, and the welds, they should essentially remain the same. But you will find that there will be some kind of a difference in the stress distribution, because now we are in the simple mode. Now we obtained the results for the simple mode, right? And we did not apply any loads on member B1, right? So whether we apply the loads for B1 or B2, it is obviously is going to affect the stress distribution in B1, right? So let us quickly see what about the stress distribution in the member B1. So what we do is that we could check one, and we just press the equivalent stress distribution. So now you can see the distribution here. Okay, so please remember this distribution. So we'll focus, I will be focusing mainly on this connector member. Here you'll find that yes, the stress is somewhere around, you can say that's between say 175 and 200, and it is going in the circular format, right? Something like this. And you find, okay, you just remember the stress distribution in the connector members. So now what I will do is that I will take you to the other mode, that is what we call as the advanced mode. And in order to show you what is done basically in the advanced mode, let me switch over to the other project. That's a Con2. Yes, in the Con2 you will find that it is the same member. So let me just put the design. Yes, it's the same truss joint, and here please remember that B1 is kept again the same as the bearing member. We did not change anything here. So only change will be there in the load effects. Okay, ribbon. So if you go to the load effects, so what I did is that I have selected the loads in equilibrium. I press this loads in equilibrium tab. Okay. So when you press this loads in equilibrium tab, what happens is that, okay, you are able to apply the loads also to the member ends of the bearing member B1. So accordingly, you will find that this particular table for the load application, it consists of everything, all the members. Look here, B1 beginning and end. I applied the loads. I applied here a compression of 300, and here I applied a tension of 0.1. And the loads in BR1, BR2, BR3, I did not change at all. Okay, I kept the same thing, that is 344 compression, 150 tension, and 156 tension. So only thing is that here I applied an additional load on the bearing member B1, right? So here one very important thing is that with application of the loads in all the members, one very important thing is that you please check whether the model has got any kind of an unbalanced forces that could significantly affect the results. For example, in this case, The unbalanced forces shows yes, there's a small force of 0.5 kilonewton. So in order to reduce this, I can add some force in the x direction. Instead of 300, I can keep it as 300.3, no problem. And here you'll find that yes, there is a small moment. This moment, which as per my perception, could be because of the eccentricities of the applied loads. Because what we know is that the bolts are not exactly oriented along the centroidal axis of the members. So let this be in the system, because this is an inbuilt or the generated moment. Okay. Otherwise, we have got the full equilibrium being provided in the XYZ directions in terms of the translation, also in terms of the rotations. So please remember, we are now in the advanced mode. So whether if you want to go to the advanced mode or not, you can just switch. For example, look here. When I press loads in equilibrium, so here you will find that we are not in the tab. Okay, we are not in the tab. I am unable to apply the loads here, right? So now again, when I press it, yes, now we are in the loads in equilibrium, right? So wherein I am able to apply the loads on all the members. Now here I want to tell you one very important thing. Normally for design engineers, what they do is that they take, for example, if you want to analyze this joint, they directly take the force resultants in the various members from their analysis package, right? The analysis package could be StatPro, SAP 2000, ETABS. So they generally take all the joint forces corresponding to a single load combination. So when it corresponds to a single load combination, it is expected that the joint has to be in equilibrium. So what you can do is that you need not to think once or twice, straight away jump to the advanced mode, because you have got the loads on all the members. So you need not to go for a second thinking whether I should keep myself in the simple mode. No, because we have got the forces in all the modes and we know that all these forces are in equilibrium. So I would recommend, if you are directly importing into the Idea Statica the joint results from an analysis program, what you straight away start with the advanced mode, and then perform the calculation analysis. So now for this connection 2 project where we are in the advanced mode, let me just calculate it so that we can directly see if at all there is any comparison, if there is any difference, and if there is a difference, where it exists. Look here. So now let me just tell you the result here. We are in the advanced mode. Yes, the plates, the strain remains the same, 0.5 percentage. Yes, the bolts, it is 95.9. So if you remember the force in the con one, it was a 94.9. So there is a 1%. It is not such a big variation. And for the weld, in the earlier case I remember it was 57.9. Now it is 57.3. That's also minor variation. So we find that essentially, as far as the connector members are concerned, the results are changed, but very minor variation. Say 0.5% or 1%, not more than that. So now I would like to also show you the stress distribution in B1, because in the present case we have also applied the loads on B1 as well. So let me take you back to the check mode, and what I will do is that I would like to show you the equivalent stress distribution. Yes, so here what we see is that yes, there is a minor change. Here you will find that there is a vertical line and the stress distribution is the same, but there is a difference in the colors. If you see, the mode, the con 1 and con 2, there is a minor change in the distribution of the stresses in the member B1. But let me just tell you one thing. So you may obviously ask me, in which case do you expect a major difference in the stress distribution of the member B1? So in some cases what happens is that it so happens that the bearing member which we have chosen in the analysis is subjected to a large amount of the load. In this case, mode 1 and mode 2 could produce a significant variation in the distribution of the stresses in the bearing member. Now, even in this case, I can tell you that the forces, the stress distribution and the utility ratio of the connected members should essentially remain the same. So to conclude, so where you are interested in only analyzing the connector members, be in the simple mode. But in many of the cases, I have observed that the design engineers straight away pick up the forces in the various members from their analysis program and import into Idea Statica. In this case, don't think twice. always be in the advanced mode, because all your forces are in equilibrium, and you will be able to obtain a stress distribution, or you will be able to get the entire analysis, the analysis of the entire joint in one stroke, which is 100% acceptable. Okay, so that is all regarding this tutorial. Okay, so thanks a lot and have a nice day.